given this function here, we want to find the hypercritical values, right? The hypercritical values. Now the hypercritical values come from the second derivative. So let's start by finding the second derivative here. So the first derivative is, all right, bring the 6 down as a multiplier. It cancels with that 6 and then decrease it by 1. So we'll get x to the 5th minus, bring that 4 down as a multiplier. It cancels. We get 5x cubed minus, now multiply by that 2, 20x. Find the second derivative, use the first derivative, then differentiate that. We will get 5x to the 4th minus 15x squared minus 20. And we get the hypercritical values by asking ourselves the two questions. First of all, where is f double prime of x equal to 0? So let's do that. F double prime of x equals 0. Now f double prime was 5x to the 4th minus 15x squared minus 20. Set that equal to 0. We can factor out a 5 for sure, and that will give us what? An x to the 4th minus 3x squared minus 4 equals 0. I'll do that right here now. We'll get 5. And you know, I think that might factor. Look at this. We've got x to the 4th, x squared. So how about if we write x squared, and then we write, say, minus 4 plus 1. So now this will factor here. This will give us 5, difference of 2 squares, right? We'll get x plus 2, x minus 2. But this factor over here, that's the sum of 2 squares. It's not going to factor using real numbers. So we're going to say that the hypercritical values occur at x equals negative 2 from here and positive 2 from here. So I'm going to claim our answers here are negative 2 and positive 2. Two hypercritical values.